Algebra 2, Lesson 6-3. Binomial radical expressions. Like radicals are radical expressions that have the same index number and the same radicand. For example, the square root, the square root of 6, actually the square root of 6, I don't know why I put the index number 2 there, okay? Or the fourth root of 12 and the fourth root of 12. Those would be what we would call like radicals. Now, to add or subtract like radicals, you're going to use the distributive property. So if I have a nth root of x plus b nth root of x, I'm basically going to add a and b and have them to the nth root of x, and it's subtraction. So combining radical expressions is different from adding them. The sum of any two real numbers is a real number, so you can add the square root of 2 and the square root of 3. You get the real number, the square root of 2 plus the square root of 3. However, you cannot combine them into a single radical of the square root of 2 plus the square root of 3 equaling the square root of 5. I notice the difference. This would be adding them. This would be badly combining them, which is incorrect. Okay, so do know that the square root of 2 plus the square root of 3 never equals the square root of 5. So we're going to add or subtract if possible. We have 5 cube roots of x minus 3 cube roots of x. They both have the same radical, so they both have the cube root of x and the cube root of x. So it's basically 5 minus 3 cube roots of x, and 5 minus 3 is 2, so 2 cube roots of x. And I'm done. Number 2, I have 4 square roots of 2 plus 5 square roots of 3. They're both square roots, but the square root of 2 and the square root of 3, so I cannot add them, so those cannot be added. Letter C here is 7 square roots of xy plus 3 square roots of xy. So that becomes 7 plus 3 square roots of xy, which makes it 10 square roots of xy. Now, here we have a lovely little application. In the stained glass window design here at the right, the side of each small square is 6 inches. Okay, find the perimeter of the window to the nearest tenth of an inch. Okay, so, if it's 6 inches, we're going to have to remember some geometry here. Okay? If each side is 6 inches of the square, that means this is 6. It does not mean this is 6. This length there is not 6. If you remember, this is an isosceles triangle. If this is 6, this is 6, this is 6 square roots of 2. How many remember that from geometry? An isosceles right triangle has a hypotenuse of 6 root 2 if the leg is 6, because if the leg is x, the hypotenuse is x root 2. So this is 6 square roots of 2, this is 6 square roots of 2, this is 6 square roots of 2 this way, which means this direction here, okay, the length of the diagonal of the square is 6 square roots of 2, so the length of the window, okay, the length of my window is 3 times 6 square roots of 2, okay, which in this case would be 18 square roots of 2. The width of my window is only 2 units of 6 square roots of 2. Okay, so I have 2 times 6 square roots of 2, which makes that 12 square roots of 2. So now I can find the perimeter, because it asks me to find the perimeter. Remember, your perimeter is 2 widths plus 2 lengths. So, excuse me, 2 lengths plus 2 widths. In this case, that would be 2 times 18 square roots of 2 plus 2 times 12 square roots of 2, which makes this 18 times 2 is 36. 36 square roots of 2, whoops, 36 square roots of 2. 36 square roots of 2 plus 24 square roots of 2, which equals 60 square roots of 2. Okay. But I want it to the nearest tenth of an inch, which means we actually have to just put it in the calculator. So if I put 60 times the square root of 2 in my calculator, I'm going to get 84.85. Okay. And this up here. 84.85. We want it to the nearest tenth of an inch, so 84.9 inches. So the perimeter of this stained glass window is approximately 84.9 inches. Now, when you have a sum or a difference of a radical expression, you should simplify the expression so that you can combine all your like radicals. Okay? You can't find the sum or difference until you simplify it. Okay? So I have 3 square roots of 20 minus the square root of 45 plus 4 square roots of 80. I have to simplify all of these. Okay? 20 is 4 times 5. 4 is 2 times 2, so I can take out the 2 and I multiply it by the 3 that's already on the outside. Leave the 5 underneath. So this becomes 6 square roots of 5 minus 45 is 9 times 5. 9 is 3 times 3, so I have 3 square roots of 5. Right? 80 is 2 times 40, and that's 2 times 20, which is 2 times 10, which is 2 times 5. Okay, so I can take out this 2 and I can take out that 2. So I'm taking out 4, multiplying it by the 4 that's already on the outside. Okay, so that makes 16. So plus 16 square roots of 5. Now I can combine and simplify. So 6 square roots of 5 minus 3 square roots of 5 is 3 square roots of 5. And then 3 square roots of 5 plus 16 square roots of 5 is 19 square roots of 5. And your calculator won't give you this without you doing a few things. And I'm not going to lie, you use your calculator anyway. You're going to have to do this by hand so that it's fair for everybody, because the 84 does not simplify radicals, and the Inspire will. Okay? The 84 will simplify them to a decimal, but it won't simplify them to an exact radical. Where the Inspire will, if I took 3 square roots of 20, and I subtracted from that square root of 45, it would simplify this down to 3 square roots of 5. So, just because the Inspire will do it doesn't mean you don't have to learn how to do it the proper way. Because remember, you're going to eventually have to do things without a calculator. SAT tests. I know a lot of college professors that don't allow the TI Inspire calculator in the classroom until you get to pre-calculus and calculus. All right, here we go. The square root of 50 plus 3 square roots of 32 minus 5 square roots of 18. Again, I'm going to simplify. This is going to be 5 times 10, which is 5 times 2. So square root of 50 is 5 square roots of 2. 32 is 4 times 8. This is 2 times 2. 8 is 2 times 2 times 2. Okay, so it's 1. So it's 4 times the 3 that's already out there. So that becomes plus 12 square roots of 2. And then 18, 2 times 9, 9 is 3 times 3, so it's 3 times the 5 that's already out there is minus 15 square roots of 2. So I have 5 square roots of 2 plus 12 square roots of 2, which is 17 square roots of 2, minus 15 square roots of 2, which just makes it 2. Okay. Now, we also have to multiply. You can use the FOIL method to multiply binomials that have radical expressions. Remember that you have to distribute. That's what FOIL basically does, it distributes. If you do distribute properly, you will multiply each term of one binomial by each term of the other. So if I have 2 plus 4 square roots of 3 multiplied by 1 minus 5 square roots of 3, I basically need to distribute them. First times first, outer, inner, last. So I'm going to take 2 and multiply it by 1 minus 5 square roots of 3, and then I'm going to take 4 square roots of 3 and multiply it by 1 minus 5 square roots of 3. And by doing that, I am ensuring that I'm getting all the parts here. 2 times 1 is 2, 2 times 5 is 10, so 2 minus 10 square roots of 3. 4 square roots of 3 times 1 is 4 square roots of 3. And 4 square roots of 3 times 5 square roots of 3 is, 4 square roots of 3 times a negative 5 square roots of 3 is negative 20 square roots of 9. Well, what's the square root of 9? It's 3, isn't it? Okay, the square root of 9 is 3, so this basically becomes negative 20 times 3. Okay, so that's negative 60. So I have 2 minus 6 square roots of 3 minus 60, so I can still combine that, can't I? So that becomes negative 58 minus 6 square roots of 3. And much like complex numbers, you put the whole number term before you put the radical term. it's more often seen as negative 58 minus 6 squared to 3 than it is negative 6 squared to 3 minus 58. Not that it really matters. It does matter with complex numbers because you always put the real part before the imaginary part. Here it doesn't matter. It's just more often seen as negative 58 minus 6 squared to 3. Now letter B here. Don't get into the habit of thinking all you have to do is square the square root of 3 and square the square root of 2. You can't just distribute the square root. Because the square root of 3 plus the square root of 2 quantity squared means this. The square root of 3 plus the square root of 2 times the square root of 3 plus the square root of 2. That's what it means. Now, if you remember, we have those special products with algebra. This is just like saying a plus b quantity squared, correct? Which would be a squared plus 2ab plus b squared. So I can use that, where my a term here is the square root of 3, and my b term here is the square root of 2. So knowing that, I'm going to have the square root of 3 squared plus 2 times the square root of 3 times the square root of 2 plus the square root of 2 squared. Right? So when I do that, square root of 3 squared is 3. 2 times the square root of 3 times the square root of 2 is 2 squared is 6. Remember, you can multiply them if they don't have the same number underneath the radical, but you can't add or subtract them. And the square root of 2 squared is 2. So now I have 3 plus 2, which is 5. 5 plus 2 is 6. Now you can FOIL it, you can distribute it, or you can use the special properties. You still should get the same answer, 5 plus 2 squared is 6. All right, letter C here, 2 square roots of 5 minus y quantity squared. I can use the a minus b quantity squared for here. Okay, I'm going to have to squeeze this in here just a little bit. Okay, so basically, this is going to be an a minus b quantity squared, which is a squared minus 2ab plus b squared. My a term, 2 square roots of 5. My b term, y. Remember, the negative sign is taken care of in the formula. So, a squared, 2 square roots of 5, quantity squared. I'm just going to erase this other stuff. I've already got it. If you missed it, go back a little bit in the video, you'll find it. I just need space here so you can see. There we go. Now I have space. So I have 2 square roots of 5 quantity squared minus, so I have 2 square roots of 5 quantity squared. There's a squared minus 2 times a, 2 square roots of 5, times b, y, plus b squared, y squared. Now, the 2 square roots of 5 quantity squared, I have to distribute the square root. So 2 squared is 4, the square root of 5 squared is just 5, so it's 4 times 5, minus 2 times 2 is 4 square roots of 5, but I have that y, which I'm going to put in front of the square root symbol. Because if you put it behind, it sometimes looks like it's underneath the radical, which it is not. Okay, so I have negative 4y squared roots of 5 plus y squared. So now I just need to simplify. 4 times 5 is 20. 20 minus 4y squared roots of 5 plus y squared. And done. Okay. Will the Inspire do that? Yes. Could you use it to check your answer? Yes. But don't rely on checking your answers all the time because you're not going to have it on the test to check your answers. Okay, because I have to make the test fair, and since the 84 will not do this, I'm not going to put any problems on the test where it's calculator only and you can just plug it into your calculator, because that wouldn't be fair to people who have the 84. All right, now, conjugate expressions. Conjugate expressions here. Okay? Conjugates are expressions such as square root of a plus the square root of b and square root of a minus the square root of b. And remember, they differ only in the sign of the second terms. Just like the conjugate in imaginary numbers, the conjugate of 1 minus I is 1 plus I. The conjugate of the square root of 2 plus the square root of 3 is the square root of 2 minus the square root of 3. So if a and b are rational numbers, then the product of two radical conjugates has to be a radical number. A rational number, excuse me. So if I have 2 plus the square root of 3 times 2 minus the square root of 3, remember this is an a plus b. A plus b times an a minus b, isn't it? And if you remember, that becomes a squared minus b squared. Now, I'll do it longhand and then I'll show you that it works both ways. So if I distributed this out using FOIL, or the distributive property, 2 times 2 minus the square root of 3, plus the square root of 3 times 2 minus the square root of 3. That would become 4 minus 2 square roots of 3, plus the square root of 3 times 2 is 2 square roots of 3, minus the square root of 3 times the square root of 3 is 3. Notice what happens to the middle terms. They cancel out. So I end up with 4 minus 3, which is 1. Okay. Now let's look at this. What is my A term here? It is 2. What is my B term? It's the square root of 3. So what is 2 squared minus the square root of 3 squared? That's 4 minus 3, which is 1. Whichever way you do it, you still get 1, which is a rational number. Okay, so when you multiply, two conjugates together, okay, you are going to get a rational number, which is good. Okay, so if we have the square root of 5 plus the square root of 2 times the square root of 5 minus the square root of 2, it just becomes the A squared. My A term here is the square root of 5. My B term here is the square root of 2. It becomes A, the square root of 5 squared, minus B, the square root of 2 squared. The square root of 5 squared is 5. The square root of 2 squared is 2, and 5 minus 2 is 3. Why is this really, really important? Well, it's really, really important when you start to divide. Because sometimes the denominator is the sum of the difference involving a radical. And if the radical expression is square roots, you can rationalize the denominator by multiplying the numerator and denominator by the conjugate of the denominator. We did a little bit of this in geometry, like 2 or 3 problems, I think. Okay, so if I look at rationalizing my denominator here, if I have 2 over 3 plus the square root of 2, I have to get rid of the 3 plus the square root of 2 by multiplying by a conjugate. My conjugate here is going to be 3 minus the square root of 2. So I can multiply the top by 3 minus the square root of 2 over 3 minus the square root of 2. Remember, it's just a fancy name for the number 1 because 3 minus the square root of 2 over 3 minus the square root of 2 is just 1. So if I multiply the top by that, I'm going to get 2 times 3 is 6 minus 2 square roots of 2. On the bottom, I'm going to get a squared, which is 3 squared, minus the square root of 2 squared. And remember, the bottom will always be a squared minus b squared. If it's not, you mess something up. So this would simplify to 6 minus 2 square roots of 2, all over 9 minus 2, which is 7. So this becomes 6 minus 2 square roots of 2, all over 7. And nothing simplifies, okay, because you can't factor anything out of both the top and the bottom that's all on the outside or all on the inside. So that's your final answer. Vector B, 6 plus the square root of 15 divided by 4 minus the square root of 15. So my conjugate here, I'm going to need more space. I'm just going to do my page right now. My conjugate is going to be 4 plus the square root of 15. So I'm going to multiply by 4 plus the square root of 15 over 4 plus the square root of 15. Right. Now, this only gets more complicated because the top is a binomial. It just means we have to follow the binomial on the top. Right, I'm going to rewrite this answer over here. 6 minus 2 square roots of 2 all over 7, my final answer. I'm going to erase this, remove space. There we go. So, I'm going to have on the top 6 plus the square root of 15, and I'm going to multiply that by 4 plus the square root of 15. On the bottom, I'm going to have 4 squared minus the square root of 15 squared. Right, so on the top, okay, I'm going to multiply 6 times 4 plus the square root of 15 plus the square root of 15 times 4 plus the square root of 15. I can actually do this as I go in my head. Some of you can't, so that's why I'm showing the long way of doing this. On the bottom, you're going to have 16 minus 15. So, I'm going to have 6 times 4 is 24, plus 6 square roots of 15, plus 4 square roots of 15, plus 15, right? Because the square root of 15 times the square root of 15 is 15. Over 1. So I need to simplify this a little bit more by combining all my like terms. 24 and 15 is 39. So I have 39 Well, 6 and 4 is 10. 10 squared is 15. All over 1, so I can just leave the 1 off of it, and I end up with 39 plus 10 squared is 15. Okay, last one. 2 minus the square root of 3 divided by 4 plus the square root of 3. So my conjugate is 4 minus the square root of 3. Multiply everything by 4 minus the square root of 3 over 4 minus the square root of 3. So on the top, we're going to have 2 minus the square root of 3 times 4 minus the square root of 3. On the bottom, we're going to end up with 4 squared minus the square root of 3 squared. So, okay. So if I multiply this, I'm going to have 2 times 4 minus the square root of 3 minus the square root of 3 multiplied by 4 minus the square root of 3. All over 16 minus, or 3, not 9. 16 minus 3. So, the top becomes 8 minus 2 square roots of 3 minus 4 square roots of 3 plus 3, because we have the negative square root of 3 times the negative square root of 3, which would be the positive square root of 9, which is positive 3. All over 13. So last but not least, 8 and 3 is 11, so we have 11 minus 6 square roots of 3 all over 13. Nothing simplifies, so we then have 13. Okay. So this is binomial radical expressions. A little complicated in spots, but not too bad. Just remember how you can add things. They have to have the same index number and the same number underneath that radical.